You may have wondered before, what is a particle accelerator? I personally have been asking this question since I was little. From news, shows, and cartoons like The Flash or Jimmy Neutron, it was a popular name used in pop cultures and media. Frankly, it isn't too complicated to understand. In this video, we will be exploring what particle accelerator is, the types of particle accelerators, how it works, the history of particle accelerator, and how it will change our future. Surprisingly, it is heavily involved in many parts of our lives. In fact, particle accelerator changed the technological part of our civilization. It supports scientific and medical research, industry and product development, and etc. This giant machine accelerates elementary particles, usually electrons or protons, to a very high speed with enormous amounts of energies. Then, it produces beams of charged particles, which are used for various researches like the behavior of particles. Currently, there are more than 30,000 particle accelerators around the world. The largest one among them is the large-hadron-collider, in short LHC, located in Geneva, with a circumference of 27 kilometers. Its budget reached roughly $9 billion and cost roughly $4.75 billion to complete in US dollar, which was roughly the same in Canadian dollars at the time. Thanks to the contribution of LHC, Higgs boson, otherwise known as the God particle, was discovered and confirmed to exist in 2012. In summary, it was a significant discovery at quantum level. With this example, we now know how amazing the particle accelerator is. Its ability allows the human race to learn more about the world we have yet familiarized with. There are two basic types of particle accelerators, circular and linear. Circular accelerator is more iconic to people who do not have experience and knowledge of particle accelerator due to its visual design. Its mechanic consists of a circular path for particles to propel in a circle. The Large Hadron Collider mentioned earlier is an example of a circular accelerator. Linear accelerator is quite different. The particles inside are propelled in a straight path. A good example would be the SLAC National Accelerator located in the United States and operated with the collaboration of Stanford University. It is one of the longest linear accelerators in the world, measured about 2 miles or 3.2 kilometers long. Linear accelerator is used for fixed target experiment, whereas circular accelerator can be used for both colliding beam and fixed target experiment. The word beam was mentioned several times earlier without a proper explanation of what it is, so let us look into it a bit more. A beam or particle beam is an accelerated stream of charged particles. They're often sped up to very close to the speed of light. The closest in the history was 99.997% of the speed of light. The particle beam is created by something called electric field, which will be mentioned later. So how does a particle accelerator work? Well, just like mentioned earlier, it requires high energy to accelerate particles to create particle beams. The very first step of an operation is the particle source. The particle source provides the elementary particles that are to be accelerated into a vacuum metal pipe with absolutely no dust or air in order to maintain a clear passage for the particles. The electric field pushes particles with electrical charge, and the magnetic field focuses and steers them along the path. As it continues to travel, the particles become faster and beam is produced. You might be wondering what electric field and magnetic field are and where they come from. Starting with electric field. Electric field is defined as electric force per unit charge. Therefore, in a formula, it would be E equals Fe over Q, where E equals the electric field strength with the unit of either N over C or V over M, which you would pronounce as Newton per coulomb or volts per meter. Fe is the force or electrical force measured in Newton, and C is coulomb, which is the charge. You can simply create an electric field by placing two plates with opposite charges parallel to each other, and we have an electric field. Place a charged particle in between and it will move toward one of the plates depending on its charge. The magnetic field is similar to electric field. We usually use the magnetic field as a tool to describe how the magnetic force is distributed. Indisputably, a magnetic field is produced by something that has magnetism. It is mathematically described as a vector field. The direction of the vector would point out from the North Pole and point into the South Pole. This is all we need to know about the magnetic field, because all we need to know about is that it stabilizes the direction of particles in the accelerator. The pipes takes part in the majority of the machine. It has the repeating pattern of the provider of electric and magnetic fields. Lots of money are spent considering how much materials like electromagnets are needed. This is where the circular accelerator comes as a great solution. Instead of building a longer path, it can be in a loop. This means that the particles will travel in a circle and the materials can be reduced, and the rest of the budget can be spent on power. Speaking of power, there is no doubt that an operation costs a lot of energy. Let us take LHC as an example. The overall electric field strength can be used up to around 8 million volts per meter, or Newton per coulomb. For some technical reasons, the number can be different. Back to the point, the electricity alone costs around $23.5 million per year, and with maintenance and other requirements, it would sum up a total of $1 billion annually. Particle accelerator was invented in 1930 by John Cockcroft and Ernest Walton, particularly seeking to confirm Einstein's theory and the famous equation E = mc squared. They built the generator out of spare parts, and eventually they were able to achieve the capacity of 600,000 volts. Arguably, we can say that the particle accelerator was invented way before 1930. The particle accelerators we have been talking about up to this point were all industry standard. When we say particle accelerators are involved in almost every part of our lives, it is no joke. Let's take an example. Televisions, which many households own, actually contain particle accelerators. Kind of. I'm talking about the component inside, cathode ray tube, invented in 1890s. It is something that we can categorize as a particle accelerator. It's just that the name didn't exist before 1930. The reason that we can say a cathode ray tube is a particle accelerator is that it involves electric field accelerating particles. Conceptually, anything that involves electric fields accelerating an object can be counted as a particle accelerator, meaning that if you hook up a battery to two oppositely charged plates, you've practically made a particle accelerator. Particle accelerators have already improved our civilization's progression of knowledge, living, and applications. For example, like mentioned before, it supports the medical researches and treatment methods. For instance, proton therapy is medical treatment specifically for treating tumors. It uses the basic mechanics of particle accelerator to produce beam and rid tumors, while creating minimal damage to healthy tissues. Another application particle accelerator can provide support is border security. I know, it doesn't sound sciencey at all. By using the same science, the accelerators can be used to scan containers and items and help identify weapons or dangerous substances. There are countless examples that prove just how underrated the particle accelerator is. Many of us never knew how much we were able to come this far in our cycle of evolution with the existence of particle accelerator. Particle accelerator is a helping hand to our society's improvement. It isn't as fancy as what we hear on the media, but it sure is reliable and applicable. From science research to home products, it is practically involved in every aspect of our life in this generation. By accelerating charged particles to create particle beams, the outcome can have various uses. It isn't something that can only be seen in professional businesses. With such a simple mechanic and wide application, the particle accelerator is one of the most iconic inventions in human civilization. In short, the whole world would have been different without the impact the particle accelerator has brought.